We're going to talk about relative and absolute extrema. If you don't remember what that means from pre-calc last year, get out. No. Max and mins. Max and mins, okay? But remember, you're doing max and mins without the calculator, okay? So the first thing you need to be aware of is that any potential max and min, because again, you don't always have max and mins, but any potential max and mins are located at critical numbers. That's why we were finding those critical numbers. And how do we find those critical numbers? We take a derivative. Okay, that's our first derivative. We take a first derivative, we set it equal to 0. Those are critical numbers. But at those critical numbers are potential max and mins. Cool. And if you remember this definition from last year, a relative max and min, a relative max is a high point, well, I guess as I'm saying max and min, or a low point, a high or low point on the graph, but not the highest or the lowest. That's what we called a relative max and min. A high point on the graph, but not the highest, not the lowest point on the graph. And let me give you a picture just so you can see what I'm saying. Like if you had this. So right here, this would be considered a relative max. Oops. Agreed, right? It's a high point on the graph right here, but it is not the highest point on the graph. The highest point would be up here. I mean, it goes on forever and ever. So there's many more points higher than it. Right here would be the relative min. It's a low point on the graph, but it is not the lowest point on the graph. The lowest point is, again, this graph keeps going and going and going. So it's not the highest or the lowest. Now, think logically with me. So yesterday we were finding the intervals where it increases, decreases, or decrease, increase, right? So if I, watch my finger, if I increase and then I decrease, what did I just find? A max or a min? Increase, decrease, that's a max. What if I did decrease, increase? What did I just find? Oh, what if I went decrease, decrease? I haven't found anything. It's nothing right now. It could be something called a point of inflection. It could be a point of inflection, but right now, if you get something that says decrease, decrease, all you're gonna just put, there's nothing there. There's no extrema. Okay? So that's all we're doing today. We're just adding one more little piece of information from what you did yesterday. You're gonna see today is the same as yesterday, just with one new extra thing. Okay? So I got 4 problems for you to show you, and then I have to do absolute max, and then we're done. Find the relative max or min of each, and then give me a little sketch. It doesn't have to be accurate. I just want kind of a sketch in your head to see what this looks like. So example 1, f of x equals 2x cubed minus 3x squared minus 36x plus 14. Okay, so again, the process is the same because you just got to determine where it's increasing or decreasing to determine if it is a max or min. So we're still going to do what we did yesterday. We're still going to take a derivative. We're still going to find critical points. We're still going to determine if it increases or decreases. We just don't have to write the intervals. So let's take a derivative. 6x squared minus 6x minus 36. Y'all agree, right?
Right.
Set equals 0. Factor out of 6. What 2 numbers multiply -6 but add to -1? 3 and 2? Yeah, -3, 2. All right. Make your number line. Oh, sorry, where are my critical values at here? 3 and -2? Okay. So -2, 3. you are going to, again, pick a number in this interval. You're going to plug it back into the derivative. And so I'll pick -3. -3 would make this -9. This would still make it negative, but two negatives multiplied together make a positive. So it's increasing. Pick a number in this interval. I'll pick 0. 0 minus 3 is negative. It's positive. Negative times positive is negative. Pick 4. Positive, positive, positive. Okay, so now don't write the intervals. That's not what I'm concerned about. If I'm going from increasing to decreasing, what is -2 then? A max or a min? Increase, decrease. That's the max. For 3, I'm going from a decrease to an increase. What's that then? That's the min. So you now know that the max is located, or a relative max, you know it's located at -2, but you have to tell me the y value. You know that the min is located at 3, but again, you have to tell me the y value. Where do you get that y value? Plug it into the original. Why wouldn't I plug it into the derivative, y'all? Because it gets you 0. It was a 0. You get zeros. I got 0 and I got 0. Of course you did. It was a 0. It was a critical number, y'all. All right. So this goes back into, as my good buddy Cody called it, back into the OG. Let's go. Original gangster function. The original gangster function. Okay. Plug it back into the original. So if I'm going to save you time here because I know you all know how to plug it back in, but at -2, it's 58. And at 3, it's -67. The original, because if you plug it back into the derivative, you would get 0. Wait, -67. So if you want to do a quick sketch of this, at -2, 58, which is like, again, way up here, and then 3 negative, which is way down here. And if you remember your end behavior for cubic functions, cubics always start down and then end up. So you start down, you would have a max right here, and you come down and have a min and then come back up. If you remember doing that last year. But that's just a sketch. Again, I'm not kind of going by accuracy, obviously. This is 58 up here. Does that make sense to you though? Right? Pretty cool. All right. Let's get going. We've got 2 more of these, and then we'll talk about absolute mins, and we're done. Oh my. F of x equals x to the 4th minus x cubed. Okay, go ahead. Take the derivative, increase, decrease, see if you're faster than me. Bet. Yeah.
I'm finished with everything. I did Black-Scholes equation.
Black-Scholes equation. That was very good.
I just looked at the...
I was going to say, I give you props for that one. Done. Boom.
Did you do Black-Scholes though?
I didn't. But I got my critical numbers to be 0 and 3/4. Do you agree? There's always somebody in the class, though, that still hasn't even written the problem down. Jack? He's squinting, so. I know. He just didn't do his homework. Yes. And he loves math. I'm very upset. That's like, it's a direct attack at me when you don't do your homework. It hurts my heart. As his Judas teacher tells him, it wrinkles his heart. My heart is wrinkled.
You do that to yourself. You can assume that if we didn't do your homework, we didn't do other people's.
It's hurting. It feels personally attacked.
It's not. It's really not.
All right, so pick a number before 0, -1, square it, put negative here. So this would be positive because it's squared. This would be negative, which is a negative. Pick a number between 0 and 3/4, everybody.
2/4.
1/2. Good job.
Oh, 1/4 is all you're going to do.
1/2 squared is going to be positive, so this really doesn't matter. This is always positive. 1/2 of 4 is 2, but 2 minus 3 is negative. So And then 3/4, so pick one, that would be positive. Okay, so question, negative, decrease. What is this?
There's no math.
Nothing. There's nothing there. Okay, that's not an extrema point. It could be a point of inflection. We'll learn about that later.
Inflection.
Okay, but now we're going decrease, increase. So this is a what? Min. You're going to find the actual y value. So it'd be 3/4 comma something. I'm actually going to save you time and find it for you. It's negative 27 over 256. Easy. And again, how did I find that? I found it by plugging it back into the OG function.
We're allowed to use our calculator for that.
You can totally use your calculator for that one. Totally, yes.
Okay.
And just so you know, so this kind of looks like, here's what this function's doing. At 0, it actually does this little dip. Surprisingly, this is actually a point of inflection. And then right here, like here's 1. So at 3/4 negative, which is right about, I don't even know, like here, it has that min. And then it comes up. It really almost looks parabolic, but it's quartic, you know, so it's a degree 4. So and it's interesting. All right, one more of these, because again, I know you've been doing them all yesterday. This is weird. All right, we really need to go over this one because the students are struggling. Shh. Take a derivative. This would be 2. Shh. This would be 3 times 2/3, which is negative 2. X minus 1 would be to the negative 1/3 equals 0. Okay. Rewrite this. Listen to me. If you rewrite this, 2 would be 2. This one right here, 2x to the negative 1/3 would be 2 over x to the 1/3, not the entire thing, just this one. Now here's the problem. You have to make this one fraction. So you're going to write that down. You must make one fraction to find your critical numbers. You will find inappropriate critical numbers if you don't do that. Like right now, what would you say the critical number would be? 0, right? That's the only way that this becomes 0. Shockingly enough, there's another critical number that you wouldn't have done.
2.
All right, so here, let's make this one fraction. So my common denominator would be what? X to the 1/3. Do you remember crisscross? So 2 times x to the 1/3 would be 2x to the 1/3 minus 2 times 1. Oh, so my critical number for the bottom is 0. That is true. But for the top, watch what happens. I set it equal to 0. And I get x to the 1/3 equals 1. What's the cube root of 1? 1. Had you not made it one fraction, you wouldn't have gotten that other critical number. So you have to make it one fraction, guys. That's, please, on tonight's homework. Make it one fraction. Okay. So now, number line, we got to see where it's increasing and decreasing. So 0, 1. Plug these numbers. These numbers here go where? To the derivative or the OG? Derivative. Derivative, go back for increase, decrease. So pick negative number. Negative would be minus up here, minus down here, so be positive. Pick a half, which would be positive, no, negative, positive, negative. I'm sorry, I'm doing this all in my head to try to save time. Positive, right? Because I'm going to be larger here and positive here. Yes, positive. Okay. So then if I'm going from an increase to a decrease, increase, decrease, what's that? Max. Decrease, increase. Min. Your max would then be located at 0 comma something. Your relative min would be then located at 1 comma something. How do I get those numbers?
Plug it into the OG.
The OG. So 0 back into this purple function right here would be 0. 1 into that purple function would be -1. That was actually a nice one. Okay. All right. So now let's just, the last thing, and I only have one example. I just want to give you a definition. Absolute maxes and mins, and then we are all done. Absolute, this is actually much easier. Absolute max. So if you remember from last year again, if you are the absolute max or the absolute min on the graph, you are the what? The highest point. Okay? You are the highest or the lowest point on the graph. There is no other higher than you. There is no other lower than you. Okay? Here's the new thing though. Maxes and mins actually occur over closed intervals. Max and mins actually occur over closed intervals. If, however, that interval is open, so if we have an open interval, your absolute max or min occurs at critical points. I'll give you a minute to write all this out before I explain it to you. Okay, so again, your absolute max and min is your highest point on the picture. It is the lowest point. In calculus, it is going to occur over a closed interval. However, they're not always going to give you a closed interval. They're going to sometimes give you open intervals here and there. Then your maxes and mins must occur at critical points. Okay, so to kind of give you an idea of what I'm talking about, okay, you have this graph that they're going to give you, and they're going to tell you, okay, it's between 1 and 5, okay? And then they're going to say, okay, find the absolute max and the absolute min in this picture. Well, obviously, wouldn't you agree this would be the max of that picture? Okay, well, this is slightly higher again. Sorry. Where would the min be?
The low?
That, and isn't this right here, isn't this what we've established as a critical point? Because I'm going from a decrease to an increase. So I know for sure maxes and mins occur at either critical points or at the endpoints of these. Now, what happens if it's not like that? What happens if I give you a graph like that and it's open over here? So if I said 1, 5. Well, again, how do I know where the max is right here? Well, the problem is I don't, because I could get really, really close to 5, like 4.9, 4.999, 4.99. But I do have what right here? What's this?
Min.
That's a min. And that's an absolute min, and I know that because it's a critical point. Okay, so you're kind of with me on this logic right here. So here's what you're going to do then. We'll just do one example because it's pretty easy. No, you don't have a max necessarily. So you are going to find the absolute max min over the interval. And they're going to give you the interval. Well, actually, they'll give you the function. Here we go. 2x cubed minus 15x squared plus 36x on 1, 5. Okay. Find the absolute max and min over the interval 1, 5 of f of x equals 2x cubed minus 15x squared plus 36x. So again, absolute max and mins occur at the endpoints of the max and min of the interval, of the closed interval, or they occur at critical numbers. Well, how do we find critical numbers? We have to do what, kids? Take a derivative. If you're not taking derivatives, this whole chapter is actually called application of derivatives because we're applying all derivatives. Okay, set it equal to 0. Two numbers multiplied at positive 6 but add to negative 5. What do we got? That would be negative 3, negative 2, yeah. Okay, so what are my critical numbers right now? 3 and 2. Okay, first things first. Are those critical numbers in this interval?
Yeah.
Would you agree they are?
Yeah.
If they're not in this interval, you don't even worry about it. If I had, let's say I had 0, whatever is 0 in there, then you don't even worry about it. Ignore it. Is it going to happen? Yes. You could get problems where the critical number will come out, but it's unnecessary. Okay? So again, we are looking for absolute maxes and mins. So what you do is you put your critical numbers, I kind of make this little table. And I put 1, because an absolute max occurs on a closed interval. So I put 1 here. I put 5 here. I put the other closed part. And then in between, I put my critical numbers, 2 and 3. Are you with me so far? Okay. And then I use my calculator and I go to original or derivative. Think. Original. And I look to see which one is my absolute max or which one is my min. So you go to your original and you find out what those y values are. Okay, so I'll just give you that 1 is 23, 2 is 28, 3 is 27, and 5 is 55. So out of all of these numbers I just gave you, which one is your absolute max? The max is right here. That is what we call the absolute max of this graph. What about right here? What's my min? Right here. That's my absolute min. If this was an open interval right here, by the way, just so you know, right here, if it had 5, you would not put 5 here. Why? It's not including 5. And so we can't find an absolute max there. It's like 4.99999. I could go higher than your 4.9. I could go higher than your 4.99. So you can't, there's no max there. That would be, I think this kind of makes sense. I don't know, maybe I'm just